Hello. In this lesson we'll review concept mapping or mind mapping, which is a way to organize your thoughts as you read through the chapter and want to understand the relationship between key ideas in each section. As we make a concept map, we typically will start with the section title, and from that section title we will branch off each subtitle that's covered in that section. There may be several subtitles in a particular section. If we put the section title in the center of a plain white sheet of paper, we can simply add arms and add the subtitle name to each line coming out from the center of that page. From the subtitle we may have even smaller divisions or descriptors of that subtitle that give you more detailed information. And so you may have several more words that describe that subtitle in more detail. And you can see that a concept map properly done will quickly turn into what we call a spider diagram that has a wealth of information in terms of key ideas and how they're related to one another. There are rules that we follow as we put concept maps together. For example, we print in capital letters one word per line so that the topics do not run together and become confusing, and we certainly do not want to be copying definitions from a textbook. We want to use color as well to differentiate key subtopic areas. And in addition, we can add images, symbols, and graphs, diagrams to that concept map that will help us understand key concepts in more detail. Now, with this as a background, let's try and build a concept map and see how it works. Let's start with a section heading, and let's call that heading Motion. And we put it in the center of the paper, draw a circle or a box around it, and then look at how the text describes motion. What are the components of motion? Well, first of all, a subheading might be called movement. Something has to move in order to have motion. Now, if you look at movement, how do you know it's moved? Well, typically its position has changed. And as its position changes, you have to have someone observing this change in position, so that person must have a reference point where they're looking from, where they're observing this movement from. So we'll just put down reference for reference point. Now, as objects move, we have to describe that motion and quantify that motion, so that movement must be over some distance. So now we've got motion described as taking place and quantifying how much of it we have. Another subcomponent of movement might be displacement. Now, displacement takes into account a couple of key ideas. First is the direction, and second would be the distance. So displacement then is defined as having both distance and direction. Now, what's another component of motion that we want to talk about? Well, we know that motion has movement. It also has speed. Now, the speed associated with motion can also be further described as how fast it's happening, and we may also want to look at the relationship between average speed versus an instant speed, or we call an instantaneous speed. And there are other components that we have with speed as well, in trying to understand how to measure it, which would be speed being defined as a distance an object moves over the time it takes to move that distance. So you have all of these components of speed that are related to motion. Now, another part of motion may be what we call velocity. And velocity is different than speed, because in velocity we take another aspect of movement, where we will call speed, and direction. Speed and direction. So velocity is slightly different than speed, and let me give you an example. If you're driving your car straight down a highway at 50 miles an hour, your speedometer says 50 miles an hour. And if you were to turn around and come back the direction that you came at 50 miles an hour, your speedometer would still say 50 miles an hour. Your velocity, however, takes into account both speed and direction. So, if you were going 50 miles an hour and you wanted to describe your velocity, you would have to indicate which direction you're going. Let's assume you were going north. Well, your velocity would then be 50 miles per hour north. Both components make up velocity. Let's look at another quick graph or an example. If you had an oval track and your speed was constant, but your direction was continually changing because you were going in a different direction around that oval, your velocity obviously would be described as very different from just your speed. Now, finally, we also want to have, there's a component of motion called graphing that is described in your textbook. And for graphing motion, you may have a graph where you have distance on the vertical axis and time on the horizontal axis, and then you can graph that relationship between distance and time, and that graph will then signify your motion. And in this case, you may have different types of motion where your speed may increase, you get tired and you want to rest, and so your speed goes to 0 and you have a flat line, and then you get energetic again and you start moving and your speed would go up. So this graph of motion, or speed, distance over time I should say, is a very good way of understanding the concept of motion. So you've got some diagrams and graphs, you've got formulas, you've got all of these subtitles, and you've got descriptors for those subtitles showing the relationship between these key concepts. This is one example of a concept map that you can use for your reference. And in our next lesson, we'll talk about specific topics in each chapter. Until then, have a good day.